The year is 1851. You're the wealthiest paper manufacturer in America in a world where electronic communication is just beginning. International trade is exploding, capital markets are doing what they've always done, and sending letters across an ocean to give updates on stocks or who's invading who is really not optimal. Your brother asks you to meet with an engineer who wants to lay a telegraph cable under the ocean. It's a new technology that just made its debut that year, connecting England to France, approximately 42 kilometers long. A feat built on the shoulders of geniuses like Michael Faraday and Samuel Morse. Yes, that Morse. But your cable will go from Newfoundland to North America, approximately 150 kilometers long. So maybe you can cut out the final week of a 2-month-old letter's journey. And that's when you have a genius idea. What if we skip the ocean? The whole ocean. Dude, that's kind of insane. Oh yeah? Yeah, bet. You raise money, a lot of money. You build vessels the world has never seen just to manage the cable. You recruit top scientists like Lord Kelvin. Yes, that Kelvin. And you spend the next 15 years failing repeatedly until it's finally done. The year is 1866. The SS Great Eastern, a ship 652 feet long carrying the entire cable from Ireland to Newfoundland, does it. Overnight, international markets are synced, news can spread in minutes, and diplomacy changes forever. Just in time for a world that's going to get pretty crazy from here on. Everything we do is run on these cables under the sea. 95% of all data is sent through them, which is why all these billionaires are investing tens of billions of dollars to make their own secure networks. But here's the problem. Managing these cables is impossible. Potential military threats, natural disasters, pirates. If anything happens to these cables, entire countries go dark for days or even weeks. I don't want to lose my Instagram feed. I don't want to die in World War III. So today, we're visiting a team at the garage that thinks they might have a solution.
What's good? How y'all doing? How y'all doing? Let's go, boys.
This is Arjun, Brian, and Vatsal, and for the past 50 days, they've been building a company called Thalassa. What are you guys building?
A high bandwidth underwater wireless network for monitoring subsea infrastructure.
Translate it in human terms.
Yeah, so you can kind of think of it as like mobile cell towers underwater. So imagine kind of a swarm of autonomous underwater vehicles, each of which have communication modems that can communicate. So you sort of get a mesh network kind of like Starlink that allows for real-time subsea monitoring. The problem is that there's a high amount of subsea infrastructure in the world. So think things like oil rigs, offshore wind farms, the telecom cables that kind of all of our data flows through. All of this infrastructure needs to be inspected the same way that, on land infrastructure needs to be inspected, but it's super expensive. The current way that it's done is they'll send out ships with crews that cost more than $100,000 per day, and they'll tether some kind of a submersible to do the inspection.
Which isn't ideal. The current way of doing things means we can't even identify problems in our system until we send someone to check on them, which can sometimes take weeks that we don't have to spare.
Kind of the main reason why this is done today is underwater communication is a largely, unsolved problem. Kind of the main ways that it's done today are either through a tether or through vehicles that use acoustics. So kind of like how whales communicate underwater. But we are the first company that's essentially going to allow this to be done wirelessly. We're solving that with, this modem right here.
So what is this little guy? This is the heart of the autonomous submarines this team is building. You see, salty seawater is extremely conductive, so it absorbs most wireless signals like Bluetooth, Wi-Fi, or 5G. In the air, they might travel a football field before weakening, but underwater, they die in just a few millimeters. So the solution? Lasers that can encode information in every quality of the beam, from their frequency or color to their brightness or size.
We're using blue-green lasers, the eye right here, to transmit a signal towards another one of these things.
And when you add enough of them, you create a mesh network, just like how Starlink works. These vessels will operate in groups covering large areas, so entire portions of our sea floor will become visible for the first time.
Light attenuates very quickly.
What is attenuation?
How energy dissipates through the water. The reason we use laser beams is because we are able to collimate them and transmit power efficiently from transmitter to receiver. We're using the specific wavelengths of light that travel furthest underwater. There's some optics in there. Optics are like just mirrors, lenses, and whatnot. So I mean, in here is just the V0.1. You've got things like a beam expander. You've just got laser driver, things like that. V0.2, I'm not allowed to talk about that just yet. So back here, these are just the gimbal motors. They allow us to kind of point this thing where we actually want it to go.
Is the major challenge this thing, or is it the vessel itself?
This thing would be the major challenge. AUVs and stuff have been designed before. Like there's hundreds of AUVs out there in the water right now. But a pointing and tracking system that can kind of maintain a communication link underwater, that's the real challenge.
What he literally means is that just keeping these things pointed at each other is very difficult. But it's a problem this team is uniquely suited to solve.
But we sort of knew each other best from like Boy Scouts. We're in the same Boy Scout troop.
Those speakers down there I built 2-3 years ago because I was just bored. Communication is all done through waves and how signals propagate through the air. And sound is just another kind of format. I was working on that telescope over here. It's just a basic like Newtonian reflector, which is meant to look like this, but it kind of fell off, broke off in transit. There's some electronics going on here that basically allow it to move by itself. I can choose a planet or star to point it at and then take like long exposure shots as the night sky moves. Pointing and tracking traditionally has always been a hard problem. Basically above ground, you have feedback mechanisms that you can use to sort of establish a link or even point at something. Like telescopes right now use cameras and whatnot to point at the star or planet that they want to point at. Underwater now, you don't have any of those feedback mechanisms. So effectively, we're operating blind underwater.
So how do they get these vessels to find each other? I can't tell you. It's proprietary, kind of like their whole thing. But I can explain this. Underwater lasers become more like cones over distance, making the accuracy less of a challenge. And once you've locked on a single time, you can make assumptions about the other vehicle that let you track it. All right, that's all you're gonna get. Go build a billion-dollar company.
We really started building right after we moved into Founders Inc., which was just about a month ago now.
I tweeted at Hubert, told him what we were building, and he was like, dude, you should like come here. So that was, I think, like 5-6 weeks ago. Bothell and Brian kind of selected all the components for that and have basically just been kind of building since then.
By the way, shameless plug, if you also have a big idea and you're looking for funding, a place to work, and most importantly, people just like you to work alongside, you can apply to Founders Inc. at this link right here. Just gonna leave that there for a second.
We think it's really a tragedy that such little is known about the ocean floor.
You know, we've explored the moon more than the ocean floor.
Currently, it's very expensive to do that. Rather than sort of covering the entire, like ocean floor of cables, we more so want this to be like a local deployable solution that, say, like an oil rig or like an offshore wind farm can kind of deploy across their asset, use it to collect subsea data, use it to do things like predictive maintenance.
This one actually shows 4 modems, so 4 of these little balls, depicting our concept for our relay vehicle. So you can imagine that this could be used to interface with 4 separate robots that are doing their own. Right now, if you use an AUV, you have an AUV that's just traveling along a pipeline, maybe weeks to months. Now you can see a pipeline burst exactly when it happens, as opposed to finding out about it like 2 weeks later.
Which will hopefully prevent tragedies when entire countries are isolated from the internet.
There's companies in this industry that predate the Civil War, so
He's always tough like that. Yeah.